Question 8. Figure 2 shows a sketch of part of the curve with equation y equals 10 plus 8x plus x squared minus x cubed. The curve has a maximum turning point A. Using calculus, show that the x-coordinate of A is 2. Well, we begin with a function and then find dy by dx. Y is equal to 10 plus 8x plus x squared minus x cubed. So the gradient function dy by dx is equal to, differentiate the 10 we get 0, differentiate plus 8x we get 8, differentiate plus x squared we get plus 2x, and differentiate minus x cubed we get minus 3x squared. Now we could set dy by dx equal to 0 and get two answers. One will be positive here, one will be negative where the minimum point is here. Or we could just verify that when x is 2 the gradient is actually 0. So when x equals 2, dy by dx is equal to 8 plus 2 multiplied by 2 minus 3 multiplied by 2 squared, which is 8, 2 2's are 4, 2 squared is 4, minus 3 times 4 is minus 12, and sure enough that gives us 0. Therefore A is a turning point with x-coordinate 2. Now that would be enough to satisfy the examiners, but what we could have done is we could have set this equal to 0, and if this is equal to 0, that also implies that 3x squared minus 2x minus 8 is equal to 0. Just taking all the three terms to the other side, so we've got positive x squared, which makes it easier to factorize. 3x in one bracket, x in the other. Well, I know that I'm looking for 2 to be a root of this equation, so let's put minus 2 in. What would we need here? Would have to be plus 4. Plus 4 times minus 2 gives minus 8. Let's just check its equivalent. There's the 3x squared. I've got plus 4x. 3x times minus 2 is minus 6x, which gives minus 2x. So you can see that the roots will be x is 2, which is that one. And if 3x plus 4 is 0, 3x is minus 4, x will be minus 4/3, which will be down here somewhere. That completes that part of the question. The region R, shown shaded in figure 2, is bounded by the curve, the y-axis, and the line from O to A, where O is the origin. Using calculus, find the exact area of R. Now we have a choice here. We could find the area under the curve. We could work out the area of this triangle here and subtract, and that would leave the shaded region R. Or we could use the fact that if you've got the area between two curves, or in this case a curve and a line, then it's just the integral of the difference of the y-coordinates at each point between x is 0 and x is 2 at the point A. In either case, I'll need to know the y-coordinate of the point A, so let's find that first. So at A, y equals, now we substitute 2 in and we get 10 plus 8 times 2 plus 2 squared minus 2 cubed. And that's 10 plus 16 plus 4 minus 8. 10 plus 16 is 26, 26 plus 4 is 30, 30 minus 8, 22. So A is the point 2, 22. Now I'll choose to look at the difference between the y-coordinates of the curves and integrate from 0 to 2. So I'll need the y-coordinate on this line. Now if A is the point 222, what is the equation of the line OA? Well, it goes through the origin, so it's just y is some constant times x. And when x is 2, y is 22, so we must have y is equal to 11x. When x is 0, 11 noughts are 0. When x is 2, 11 twos are 22. So I can now say that R is the area that you get when you integrate from 0 to 2 of the y-coordinate of the curve minus the y-coordinate of the line. So let's call that y curve minus y of the line dx. And what does that give us? That's the integral from 0 to 2 of, well, the y of the curve is 10 plus 8x plus x squared minus x cubed. And now I'm going to subtract the y coordinate of the line, which is 11x, so it's minus 11x. And we can, before we integrate, we can simplify that a little. We've got 10 plus 8x minus 11x is minus 3x plus x squared minus x cubed. And now we perform the integration. Integrate 10, we get 10x. Integrate minus 3x, minus 3x squared divided by the new power, 2, plus x cubed, when we integrate x squared, x cubed over 3 divided by the new power, minus x to the power 4 over 4. And that's between 2 and 0. So a bracket minus a bracket, substituting the 2 in first, 10 times 2 minus 3 times 2 squared over 2 plus 2 cubed over 3 minus 2 to the power 4 over 4 minus the second bracket. Now the second bracket, when we put 0 in, each of these terms will become 0. So the whole of the second bracket will be 0. So what does that give us? 10 times 2 is 20. 2 squared is 4, minus 3 times 4 is minus 12, divided by 2 is minus 6. This will be 2 cubed is 8, so 8 over 3, minus 2 to the 4 over 4. 2 to the 4 is 16, 16 divided by 4 is 4, so that's minus 4. So that gives us 20 minus 6 is 14, 14 minus 4 is 10, 10 plus 8 thirds, so 10 plus 2 and 2 thirds is 12 and 2 thirds. Or as an improper fraction, 12 threes are 36, 2 more makes 38, we could give the answer as 38 over 3. And that completes question 8.